Hello and welcome to another episode of the DigiTeacher. This week I'd like to look at some really cool extension blocks for the Microsoft Microbit MakeCode platform that have become available. They're generic blocks and they're designed for robots, and they've got a simulator. So the MakeCode platform already has a simulator for the Microbit chip. So as kids program, they can see what their program is doing, and it allows you to play and tweak and modify and create. Absolutely great, and you can do it all on the web. You don't have to download it onto the chip to test it. Now you can do pretty much the same with robots. So the simulator shows line following, it shows obstacle avoidance, or just movement around the screen of the robot. So let's get into it. So recently on GitHub, some code was released, Microsoft/Microbit-robot, which is universal robot blocks for MakeCode. I'll put the link in the description. And these are kind of generic blocks that work for different robots. So DF Robot McQueen, the Forward Education Smart Vehicle, KittenBot, there's a range of them, and no doubt more will come out. And there's some tutorials, but fantastic feature, what it provides is a simulator. So already in MakeCode you've got the simulator for the chip itself, so kids can program online and see what happens to the chip. They don't have to constantly download it onto the chip and test it. So this is a simulator, and it's showing line following. And those blocks in the middle are obstacles. You can see it's got some obstacle avoidance there. So by using the simulator, you can get kids to be able to code some robotics without even having a robot, potentially, which might or might not be useful. And you've got tutorials. So this is showing in different programming languages. It uses with block code, Python, JavaScript, and fantastic feature. There's some tutorials there as well. Getting started, light and sound, and the line follower code. So let's get into it a bit. Let's go into MakeCode, and the first thing you need to do is find that extension to get those blocks. So if you click on extension, it's called Microbit-robot. So if you search that, the code will come up here, and you can see Microbit robot, and you just click on it and it adds the extension, and you can see here are the blocks that it's added. So let's put together simple line following. Now line following code can be very, very complex. In the past I have a DF McQueen robot that I use with my classes, and I've used line following, and the code is a horrendous sequence of nested ifs that require the fortitude of a saint. Much simpler here. So first thing you need to get is the robot start block. You can put that on start, and you can then select whichever robot is available. And I'm assuming this is still in beta, that more and more will become available over time. So I'm going to put in the DF robot. So you can basically code it here, and it then gets transferred, and you can see the moment you've got that block of code, you've got the simulator there. So let's see what's kind of available. One cool feature is you can set the color of the LEDs. So if I turn it yellow, you'll notice there it's got yellow lights flashing. So to get some line following code, I need to get one of these. Some robots have more than sensors. The McQueen, I think, has a left and a right sensor, so I'm just going to use those. And I'm adding that event block. So this would be the case where the left sensor and the right sensor are both off. So let's take the case where both sensors are on. In other words, the robot sensor is picking up the black of the line on both the right and the left sensor. Well, if it's on the line, you want it to continue straight. So you would then use the robot motor steer, and 0 would be dead ahead. So you would use that. This, I believe, is the strength, the motor strength. So you can kind of play with that a little bit. And let's see what it does now. In the emulator, well, the robot is just steering ahead. There's nothing about it going off the line, so it just keeps on steering ahead. So what about the case if it's off the line? If I right-click that and duplicate it, well, let's say that the left sensor is off and the right sensor is on. So the right sensor is on the line, it's gone off to the left. So you want it to turn to the right. So we want basically to steer to the right. So I'm going to get it to steer slightly to the right. Use small values here. If you use too big values, it kind of veers quite radically. So if it goes off to the left, it's going to steer to the right. And then we want the contrary case as well. If it's on black to the left, but it's gone off to the right, we want it to steer back to the left, and that would be a negative direction. And we also want the case where it's gone off the line completely. So both of these are detecting white space. It's off the black line. It's not running at all. Well, then we want it to kind of turn around quite a bit. I don't think it matters if you go left or right, maybe about 110, 120 degrees to try and find the line again. So we test that code. You can see it's gone off the line, it's found the line, and still searching for the line. It keeps on going off the line, and that looks quite radical, that. But it's following it a bit better now. So one thing you can do is give this as starter code. So you can give the kids this as starter code and then get them to read the code and try and understand what it's doing. You could also include some mistakes. So for example, if I put way too much there, let's see what that does. When it loses the line, so it's still on the line, it kind of lost the line, it's going all the way around, it's going in the wrong direction. So obviously that 200 is a bit too much. So you want them to kind of play around and try and find values which are going to make it stay on the line. So it's quite good code for giving them some starter code and then getting them to play with it. You could also add some obstacle avoidance. So if you have an obstacle, what would happen there? Well, one thing that is available to the robot is robot arms. So if it's an obstacle, you want it to pick the obstacle up. So you get to right up close to the obstacle and then use the robot arms to pick it up. So thinking about what pedagogical approaches you might use, I think quite a good one would be PRIM. So that's where you get students to try and read the code and understand the code before they do any coding themselves. So you could give them the line following code, maybe with some mistakes in it, or with some things left out that need to be added. So maybe you've got, it's picking up the left-hand sensor but not the right-hand sensor. They have to take what they know from the left-hand sensor and bring in the right blocks and code it to pick up the right-hand sensor. You could do something like that. PRIM, so predict. They read the code and then they make a prediction what the code does. They run the code and see if they're right. They investigate. They modify and make new code. So you could add additions, get challenges, take this basic code and add to it, make it do something else. So I think those are all some pretty neat ideas, and this is a very exciting development on the MakeCode platform. Try it out, I really would. If you enjoyed this video, please like and subscribe, leave comments, share. Let's get this channel off the ground. Let's make it popular so that lots and lots of computer teachers are logging in every week to talk about and think about how we teach computing.